simplifying, our first step was to go to the numerator and GCF or factor if possible. Go to the denominator, GCF and factor if possible, right? That was our first step. Same thing for multiplication. It's just now we have 2 numerators and 2 denominators. It just takes longer. But same steps. So we're going to do the same thing as we did for simplifying. We're going to look at the first numerator, the first top on the left. X plus 1. Can I take anything out of that? Trick question. No. X plus 1. The denominator, we have x plus 3. Can I factor it or GCF? No. Multiply, the little closed dot is a multiplication symbol. The reason why I like it better than multiplication symbol is because the multiplication symbol looks like an x, and most of the variables you use are x, and then it just gets really complicated. So I use this closed dot. 2x plus 6, what can you take out of that? A 2. And when you take a 2 out, you're left with x plus 3. And then I always put the 2 in its own brackets because it's being multiplied. And then on the bottom, we have x squared plus x. What can we take out of there? An x. Exactly. X out of x squared, you're left with x. Plus 1. Thank you. Not 0. It doesn't cancel off. X divided by x is a 1. And then I can put that x in its own brackets. So first step was make GCF for difference of squares, all the numerators and denominators. Same thing as simplifying, right? Second step, before I go to cancel anything off, I have to state NPVs. In this case, I just usually have more because I have 2 denominators instead of 1. So I have to do x plus 3, x, and x plus 1. So my NPVs are going to be x can't equal negative 3 because negative 3 plus 3 is 0. What's this one? Just 0. And then x plus 1, negative 1, because negative 1 plus 1 is 0. And we have to state all the things that are going to make the x be 0. So we've done our NPVs. If you're someone who's still having problems with NPVs, please come in and ask questions. Scheduled help and lunch, I'm here. Now, that was the first step, was to GCF for difference of squares, the tops and the bottoms, the numerators and denominators. Second step, state NPVs before I cancel. Third step in simplifying was anything on the top that's the same as anything on the bottom, I can cross it off, correct? Same thing here. Anything on the tops that's the same as any of the bottoms, you can cancel off, even across the multiplication sign. So, you can cross off the x plus 3, you're right, correct? Now, what if there was 2 x plus 3s on the top and 1 on the bottom? Could I cross off both x plus 3s on the top? No, it's 1 for 1, right? All for 1. So we have an equal sign here because this is equal to this expression. Then the x plus 1 and the x plus 1s cancel because 1's in the top and 1's in the bottom. And does the 2 ever go away on the top? X on the bottom? No. So all we're left with is 2 over x, and then x cannot equal negative 3, 0, negative 1. So not much different than yesterday, right? Just more work, technically. Okay? Yeah.
Kind of really off topic. Just pop from the term on the money. Like if you throw a football or like a baseball, like, oh, that was right on the money.
That's a good question.
You work on B and C, and I will Google it. I will use the Google. I am recording this. I'm recording this right now by accident. I will use the Google, and so. This one up here, we have 12x cubed. Can we take anything out of it? No. So it's going to be a 12 times an x cubed. And then on the bottom, what can I take out? And an x. 3 and an x. When you take a 3x out of 3x squared, you're left with x. Plus 6x divided by 3x, you're left with a 2. And then the 3 and the x can go in their own brackets, right? Because they're multiplied together. Nope. And then, oh, I'm recording that. That's good too. And then, what can you take out of the top on the right-hand side? A 4x squared. And then you're left with an x plus 2. And then these are in their own brackets. And then a 5. Most people can get to here, and then they're like, oh, no. Oh, no, what do I do? Okay. So let's ask ourselves, What do we have to do next? NPVs. So 3 and 5, do I get any NPVs from those? No, because they don't have variables. X has an NPV of what? 0. And then X plus 2 is -2. Okay. So the X plus 2's cancel. I have 1 there and 1 there. And then everyone's like, uh-oh. 5 doesn't get you an NPV because it doesn't have a variable. It'd be 5 cannot equal 0. Yeah. And then we say, okay, I have an X on the bottom. And how many total do I actually have on the top? 5. Because remember, it'd be like having X cubed, like having X times X times X. And X squared, like having X times X. How many of those are there? 5. Okay? You don't actually multiply them, right? It's like adding them when you have like bases. So I can take one X out of either of those, but not out of each one, right? It's 1 for 1. So I'm going to take an X out of this one just because I feel like it. So it's going to knock this one down to X1. If I took it out of this one, it would knock this one down to X squared. It doesn't matter. You'll still get the same total number of X's in the end. Okay? Now, can I cancel out any numbers? The 12 and the 3. I can take a 3 out of both of those. What if the 3 was here? Could I do it still if it was across from each other? You could, as long as it's on the top somewhere and on the bottom somewhere. Okay? So if the 3 and the 5 were switched, I could still do it because the 3 would still be on the bottom. So 12 divided by 3 is 4. 3 divided by 3 is 1. And then the 4 and the 5, can I do anything? No. What about this 4 and 4? They're the same. Can I not cancel them off? They're both on the top, so I can't cancel them off. Okay? So I think I'm done. So I'm going to write it over. If in the end I'm not done, it doesn't matter. When you go to the next step and you put them all together, you might see, oh, there's still something else I can cancel. Then cancel again. Not a big deal. Okay? So let's multiply what's left over. 4 times 1 times 4 times 1 is 16. So I multiply all the numbers together first. Then I have X cubed times X. What is that? X to the 4. Because remember, it's like having 3 X's and 1 X. Total is 4 X's. Okay? So you actually add the exponents because you're adding them up. This would have an X times an X times an X. And this is an X. How many X's is that? 4. So that's why. And then on the bottom, you're just going to have 1 times 1 times 1 times 1 times 5. And then X cannot equal 0 and -2. Okay? Let's look at C. In the top of C, so in the numerator on the left, in the top on the left, what can I take out of them? 2x squared. So it's going to equal, because this expression equals the next expression, so I put equal signs, right? 2x squared. When I take 2x squared out of 2x cubed and left with x, minus 2. This 2 and x squared, do I have to put them in a bracket together? Do they have to be connected in a bracket? No. They're multiplied, so they can be in their own brackets. The denominator, I have 3x squared minus 9x. What can I take out of 3x squared minus 9x? When I take a 3x out of 3x squared, what am I left with? An x and a -3, yes. Do I keep these in the same bracket, so unless there's a 3x up there, I'm not canceling it off? They're in different brackets because they're multiplied. There's no connection. Times x squared in the top in its own brackets. What about the bottom, x squared minus 4? Difference of squares. Honestly, on the test, if people do poorly on the quizzes and tests, I find it's just they forget the difference of squares. Difference of squares exists. Like, you just forget to do it, right? You like, nothing crosses off. So remember that difference of squares does exist, because that's usually where people forget. So x squared minus 4, the square root of x squared is x, so that goes in the front of each bracket. The square root of 4 is 2, so that goes in the back of each bracket, plus or minus. Now, before I go to cancel, I have to state NPVs. So I have 3. Can it ever be 0? No, it's a 3. X. This would get me x can't equal 0. Negative 3 would get me actually positive 3. Because it'd be 3 minus 3 would get me 0. So positive 3. This would be a negative 2 because negative 2 plus 2 would be 0. And this would be a positive 2. So we always put them together plus or minus like that. If you wrote them out separately, you're not wrong. They'll just probably put them together on the diploma. Okay? Now we can cancel. I'll use a different color. So, what's common to the top and the bottom, guys? X minus 2, yep. What else in the numerator and the denominator? An x. Can I cross these x squareds off? They're the same. No, they're both on the top. So it's 1 for 1. So can I take this x out and then this 1 out of here and 1 out of here? No, it's 1 for 1. So I can cross it off of this one and make this be a 1, or I could have canceled off this one and made it be a 1, but not both. Right? Then we done. So what I told you is the worst case scenario is often people want to make it be more simple. They want it to be like 2 over x. So when it's complex like this, they're like, I must be missing something. So I'm just going to cancel off random things. And then it will be nicer. And then I will be happy. And then I will be sad. You may be happy, but I will be sad. So don't do that. Okay? Because our coefficient is 2 and 3. There's nothing I can take out of those, right? I can't take like, I don't know, this 2 and this plus 2 at the back here. They can't go away, right? I need x plus 2. That's the only way that's going away. Right? We agree? So it's going to be 2x and x squared. What's x and x squared? X cubed. This is 1x and 2x's, so that's 3. So you have 2x cubed. And then the denominator, we have 3 and x minus 3 and x plus 2. And then behind it, x cannot equal 0, 3, and positive negative 2. So do you see if you state the non-permissible values after you cancel, we would actually be missing the 0 and we'd be missing the positive 2, right? And we'd be wrong. So we always have to state NPVs before we cancel. We agree? Okay. Okay, I want to give this one because it's more of the style of could be a diploma style question. So with the appropriate restrictions, so I don't have to state NPVs, it's saying with the appropriate restrictions, the product. You guys need to know what the heck that word is, because if they say that on the diploma, you can't be like raising your hand and asking me, because no one in that room teaches math. You are going to be in one of the, usually it's the cafeteria, and there will not be a math teacher in there. I'm not allowed into that room. I don't want to go into that room, first off, because I would never want to be partial to you. But anyone in there, I go into like social and English, and they're like, Mrs. Lepp, could you possibly give me the answer to like the definition? I was like, first off, if I could, I can't. Second off, I have no idea what the definition is to that. I don't even know how to start for you. So they put me in those things because I can't even help. Like even if I wanted to, it ain't gonna happen. Okay? So you need to know the words and what they mean because no one's helping you. They can't. So what does product mean? Product is the answer to what? Multiplication. So they're asking you to multiply these. If I said sum is the answer to a what? Addition. Difference is the answer to a subtraction. And what would be the answer to division? Quotient. Okay? So we have product. Product of this reduces to a whole number. So what they're saying is this lovely rational will reduce to a whole number. Whole number, remember, natural numbers is what you need to remember. Natural numbers are the natural numbers you speak from little on. So what does a normal little kid start at?
0.
No, I've never seen a little kid be like 0, 1, 2, 3. No.
1.
Oh my gosh, you were a crazy child. I mean, they normally start off at like 1, right? And then they go 1, 2, 3, 4, right? Naturally, you start. If you're super smart, maybe you start at 0. We're going to go with the average child, and they normally start at 1, okay? So 1, 2, 3, 4, 5, 6 are the natural numbers you would say. So that's the natural numbers. Whole numbers are the natural numbers plus the number with a whole. 0. So that's when you start getting a little smarter. Or maybe you were just genius child and you start off with 0. Yeah. No, not always. So 0, 1, 2, 3, 4 would be the whole numbers, right? So all the natural numbers you speak plus the one with the whole. So the whole numbers. Natural numbers are the ones you naturally speak. Integers, you got into grade 7 and you were like, oh no, there's negatives in the world. What is happening? And that's the integers, right? Negatives and positives. But no decimals. And then you have rational and irrational. Irrational are decimals that do not stop, do not repeat. They're like crazy. They don't repeat. Well, kind of crazy if you could repeat themselves. But they don't stop and they don't repeat. Like pi. 3.14159 keeps going. Or E, which is the one we're going to look at. E is with logs. It's 2.78, same thing. It's just another decimal that doesn't stop, that they gave a letter to it. Like pi, they gave a symbol to it, right? So those are irrational. Irrational numbers can never be turned into a fraction. So that's another thing too. So they want us to reduce to a whole number. So 0 or positive. It has to be a whole number, or at least it has to be a positive number, because in our numeric response boxes, we can't have negative numbers. So if you get a negative answer on your diploma and you want to fill it into the numeric response box, think, I'm wrong. I did something wrong, because you can't put a negative in. Some of you, I get like a little negative symbol in the first box. You can't do that. Some of you are like, meh, must be positive, and put a negative symbol in front of the first box. No, if it's negative, you made an oopsie. Okay, you can't have a negative. The only way you could have a negative is if they asked you for the absolute value of that function, which would turn it to a positive, which they don't usually do in 30-2. So if you have a negative, it ain't going to happen. You can't fill it into numeric response box. There is no negative bubble. Okay? So this reduces to a whole number. So everything needs to cancel. All the letters need to cancel off. It's going to result in the whole number k. They're going to label it that whole number to be k. Then they want the value of k in the box. Okay? You always fill in left to right, like you read. So you fill in left to right. If you only have one number, you fill in the first box and you're done. They do not all need to be filled in. The decimal bubbles only occur in this one and this one. There's only decimal bubbles under the two middle ones. So if your answer was like 0.4, which this one won't be because it needs to be a whole number and whole numbers are not decimals. But say it was 0.4, you'd have to actually go 0.4. You can't just go decimal 4. There is no decimal bubble in the first box. Okay? So you'd have to start off with 0.4. Okay? That's just reminding you about what those boxes have. So let's go through and try this one. They want the product. They want us to multiply it. So what can I do to the top left? Take out a 12. So I have equal to, because this expression is equal to the next one. Take out a 12, and I'm left with x minus 2. The bottom, I can take out a 3, and then I'm left with x squared minus 4. The 3 can go in brackets. The 12 can go in brackets. What do we know about the x squared minus 4? It can be difference of squares. Yes. So this can actually break into x plus 2, x minus 2. You could do it in a separate step. I'm just going to do this so that you know what I did. So it can break into x plus 2, x minus 2. The top right, or the numerator on the right, you can take out a 6. And then you're left with x plus 2. The 6 goes in its own brackets. And in the denominator, you're left with a 2 on the right. Do I have to state NPVs in this numeric response question? No, it says with the appropriate restrictions. So they're saying the appropriate restrictions exist. You don't have to say them. Okay. So x plus 2, x plus 2, x minus 2, x minus 2. Shh. 12 and 3, I could take out a 3. Could I go 12 and 2 like this? Yeah. I'm going to go this way. 12 divided by 3 is 4. 3 divided by 3 is 1. 6 and 2 I can take out, so 2 divided by 2 is 1. 6 divided by 2 is 3. So I'm actually left with 4 times 1 times 1 times 3 times 1 times 1, which is 12, over 1 times 1 times 1, 1 times 1, which is 1, which is 12. Because when the denominator is 1, I can cancel it. Fill in left to right, and I'm done. I do not want to see 12.0 on your chest. So many people do that. No, you'd actually be wrong. It doesn't say to the nearest tenth. It just says whole number, right? Whole numbers don't even have decimals, actually. They technically do. You can decimal 000, Don't do that. Just fill in and be done. If it says to the nearest tenth, then you'd fill it in. If it happens to fill in all the boxes, great. If it doesn't, you stop. So if it says whole number of 12, you put 12. Do not do 12 decimal 0. You were actually wrong. Okay, that's not a whole number. That's to the nearest tenth. That's a decimal. Okay? So I'm going to give you about 4 questions out of your textbook. That's 4. 4A, 5A, 6AB. Ooh.